Welcome to day 9. Today we'll be talking about creating a statistical analysis plan. The question that naturally arises is, what is a statistical analysis plan and why do we need it? Well, to help us understand that better, let us consider the same reasons we need a plan when building a house. We need a plan because we need to communicate with the owner of the house and to communicate with the zoning office. Obviously, we don't want a scenario where we build a house first and then the zoning office comes and says, well, this house was not built to plan, and so you have to tear it down and redo it again. So in the same way, we want to create a plan for our analysis that says that this table will be here and this one will be here, and this is how we're going to capture our descriptive analysis. That way, when we share the plan with others, for example, our supervisors or our mentors, they can look at the plan and say, well, you missed something here. You missed a confounding variable here. Go back and evaluate it again. And so that makes the process very efficient and reduces back and forth. And most importantly, it eliminates medicine after death, where we do the whole work and then it is only then that feedback is provided. So a statistical analysis plan keeps us modest. It keeps us, also very importantly, keeps us honest, because we have already specified in this plan everything that we wish to do, so that it is no longer a case of us moving the goalpost as we go. And that's why we need a statistical analysis plan. So let's see how we can create a statistical analysis plan on the Chisquares platform. We'll go over here and let's go to our project, and you'll go to Analysis Wizard and come to Analysis Suggester. That's where we'll create our analysis plan. In this research question, we are trying to do a case study on. We're looking at the relationship between living in a rural area and the likelihood of using tobacco products. So the research question is there an association between rural or urban status and current use of diverse tobacco products? So let's come here and click on Analysis Suggester. The platform will ask us to provide the primary outcome, the single most important outcome variable. There can only be one primary outcome in a study. You can always click on the show justification to explain what the requirement is all about. So here it tells you, for example, that just like a ship can only have one captain, so your study can only have one primary outcome. In our case here, our primary outcome will be current use of any tobacco products. So let's select that. So this is the single most important outcome. You might have a lot of outcomes, but ask yourself, which is the single most important outcome of all of them? The other ones can now go into secondary outcomes. Our secondary outcomes are very important because they demonstrate coherence. When we see that everything is going in the same direction, that increases the likelihood that what we have seen is actually a signal and not just noise. So in here, our secondary outcomes could be the other tobacco products we're interested in. For example, cigarette smoking, and then let's add the other ones. Current use of electronic cigarettes, cigars, smokeless tobacco, and current use of any combustible tobacco products. So those are our secondary outcomes. Next question, choose a predictor or variable. In this case, our main variable is, this is the variable here. It is a categorical variable. Then the last question says choose the main demographic variables or other key covariates in your data set. So this will be our covariates of interest, our potential confounding variables. So we can select them here. And this will be things like age. Let's sort them by order created date, most to least recent. So this will be things like your occupation, which is categorical, but also we include things like, let's search for the others. Whether you have a disability, I'm following the instructions from the guidance document in our schedule for today. It will include things like BMI, your sexual orientation, poverty index ratio, which is a marker for poverty, marital status, education, race, age, category, gender, region. So yes, those are the variables we're interested in as potential confounders. And when we're done, we click on done selecting and we specify their type. In this kind of cases, the platform doesn't know whether a particular variable is ordinal or nominal. So it allows you to specify the type. In this case, these are all unordered categories. So I'll select them accordingly. This unordered categories are also called nominal because there's no inherent ordering in those variables, whereas variables that have an inherent ordering are called ordinal, categorical variables, I mean. So now that we've selected our primary outcome, our secondary outcomes, our main predictor, and our potential variates, we can now suggest analysis. So in a nutshell, the platform sets up the design as though it's a causal question where we have an exposure and an outcome. Now, even if your study is a descriptive study, you should shoot for the stars. If you miss, you can always hit the birds. So this is a very useful framework to help set up your study. Now let's click on suggest analysis and let's see what comes up. So the platform takes all of this information that we have and it will then synthesize the information and suggest to us that here your manuscript should have X number of tables, and table 1 should be this, and table 2 should be that. Let's see what happens in a minute. Let's give it a second to finish its processing. Okay, so now we have the suggestions provided by the platform. As you can see here, it has suggested 4 tables. It says that table 1 should be characteristics of a study population, which is usually the first table in any given manuscript. When you walk into a room, first introduce yourself to the audience. In the same vein, when we're doing a study, it's always helpful to, first of all, provide an overview of a study population. And in this case, if you click the arrow here, it will show you the variables that the platform recommends should be in that particular table. So here it has listed all these variables for us, and you can see the number of missing values accordingly. Then next, it says that table 2 should be overall and stratified prevalence estimates of the selected outcomes among the study population. If we depress that arrow, we can see it has given us certain variables that will be stratification variables. And then we also have the variables that will be outcome variables. So the primary and secondary outcomes are listed here as our outcomes in our descriptive analysis. And then the other variables are the stratification variables. So in other words, it's saying in this table, let us look at the percentage of adults who use cigarettes and e-cigarettes and cigars and so on and so forth. And let's calculate that in the overall population, and let's further break it down by region and gender and age and so on and so forth. So that's what it is suggesting in this table. And here you can see the justification that the platform has provided for giving you that particular analysis. So let's look at the next table it has suggested. Then the next table it suggested is adjusted odds ratios calculated in a binary logistic regression model, assessing factors associated with current any tobacco use among the study population. So it has suggested a regression model here for us so that we can better understand that relationship between the exposure and the outcome. If you do not like the regression model the platform has suggested, you can click on this button that says alternative models, and you will see other models that are also suggested which could be equivalent given the kind of outcome in question. And so here, if we depress the arrow, we can see the variables that are suggested in the model. And then lastly, the platform suggests a sensitivity analysis. Sensitivity analysis that are done to test our assumptions or to test whether our assumptions are robust. When we say something is robust in research, we mean that the value stays more or less the same despite changing assumptions. If we made a small change in our assumptions and the results just change dramatically, it means that our results are not robust. So in this case, the platform has suggested sensitivity analysis to look at the outcome in a more robust manner. Here it has suggested that we explore the relationship in a binary Poisson regression model. And if you look at the justification here, it provides why it suggested that particular regression model. In general, when our outcome is very common, we don't want to use logistic regression because it overestimates the likelihood of the event occurring. When we calculate prevalence ratios in a Poisson regression model, they are generally more conservative. And so in this case, the platform has said, but it's a very common outcome. So while you can use a binary logistic regression in table 3, I suggest that you explore the relationship further in a more conservative model, which will be calculating prevalence ratios with a Poisson model. One thing that people also find confusing is that they might say, well, but Poisson regression model is for count. Well, a binary variable is a count. It's a count that just ends at 1. So you can absolutely use it to estimate prevalence ratios in lieu of odds ratios. Now, at the top here, the platform also provides you several diagnostics. So if you click up here, you see View Variable Selection Diagnostics. This allows you to explore for confounding and for collinearity. So remember that the relationship of interest was what is the association between rural or urban status and current tobacco use. So we want to see absolutely if those variables that were selected are actual confounders. So if we click here, the platform takes all those variables and empirically tests for confounding. Remember that a confounder is a variable that has to meet 3 criteria. It must be independently associated with the exposure, it must be independently associated with the outcome, and it must not lie on a causal pathway. And so the platform assesses confounding at the 20% alpha threshold, which is P0.2, but you can always change that threshold and choose whatever you want. So if you want to use, for example, P of 0.1, you can simply select that, and the platform will then reassess the list of confounders at that new threshold and display the new variables that meet that threshold. So the variables that have been displayed here are those that meet those 3 criteria. They are independently associated with the outcome at this P level. They are independently associated with the exposure, also at this P level, and they do not lie on the causal pathway. And so that's how the platform helps you to determine whether or not the variables that you have chosen are confounders or not. When the variables are listed, you can also click here to see a more detailed breakdown of the analysis that the platform did in the background for it to come up with those results. So if we click here, for example, it's going to then display to us all of the bivariate tests that were done by the platform to be able to come to the conclusion that so and so variables were confounders of the relationship between the exposure and the outcome. So here in this context, at P0.1, these are the variables that have been determined to be confounders of that relationship between rural-urban status and current use of any tobacco products. So let's quickly wait for this to display so we can see the bivariate analysis that was conducted by the platform behind the scenes to be able to generate this result. And to be clear, all of this is done with statistical algorithms. There is no AI involved in any of these calculations by the platform. So the whole point of planning is that now you have this list of variables. You can now plan. Now you know definitively that these variables are confounders in your study. So if you wanted to remove some variables that were not confounders, you can remove them at this point. Again, the whole point is to allow you to take decisions so that you don't overstuff your model with a lot of variables that are not even doing much, that are perhaps not confounders and are just adding noise without doing much. So let's quickly look at this, the bivariate result. So here, the output is displayed here. You can see part 1 shows you the test for association with the outcome. You have the different variables here, and then this is the dependent variable, which is our outcome. And you can see the p-values here. And then part B looks at the test for association with the exposure, in this case, rural or urban status. The same thing applies here. And so this is how the platform helps you determine which variables are confounders or not. The same thing for collinearity. If we click there, the platform also helps us to determine which variables are collinear variables. So the goal is that if we determine that some variables are collinear, then we would remove them from the analysis. Collinear variables are harmful because it's like having a lot of employees who are perfectly redundant. You know, if you have two individuals who are doing the exact same thing in your workplace, the question is, why are you paying the second person? They're just giving you anxiety overnight because you're worrying about, geez, how am I going to make the payroll for these people? All right. That is the exact same thing the model faces. When it has redundancy, the model is anxious. And we call the model's anxiety inflated standard errors. And so we don't want that. So here you can look at the degree of collinearity between the variables, and then you can make a decision. Here we can see there's not much collinearity. There is some degree here between education and poverty index ratio, but it's not much. Here too we can see some between age and marital status. But overall, these are literally quite low levels of collinearity. So we don't have a problem of collinearity here. So bottom line, this is how the Chisquares platform allows you to be able to plan for your analysis. It first of all suggests your tables for you, and such that when you are ready to do your analysis, all you need to do is click on run this analysis. And then you click estimate. The platform will then take that information, analyze the data for you as requested, and then you can proceed with your work. So this is a requirement. Whether you're doing it with a software or manually, it is very important for researchers to plan their study so that they don't get surprises at the end, so that all the feedback you need is provided at a very early onset. Okay, I'll be looking forward to reviewing your assignments and providing feedback. And if you have any questions, please drop them on LinkedIn. Thank you very much.